Welcome back for another flight computer video. Today we are looking at the Jardur Flight Calculator Model V. And Jardur was known for making aviation chronographs. This was their flight calculator, probably from the late 30s or early 40s. And it's a two-sided calculator. On this side, we calculate the wind corrections via the law of sines. And on the other side, we have time speed distance calculator, as well as a true airspeed calculator. This one was made of a plastic celluloid. It's got a little bit of warpage there. It has red ink and blue ink, which I think really makes it stand out. And you may recognize this design from other types of flight calculators that have been branded as promotional. So this is a Motorola promotion product. You can also see SO flight computers that look just like this. And something that's fun to note about these is they were manufactured by the Perigraph Corporation. And that corporation is still around and still producing circular calculators today. So you can actually still order different products from that company. Okay, so what we'll do is we'll walk through a wind problem and a time speed distance problem and talk a little bit about what's the advantages and disadvantages of this particular device. So on the wind side, I'll just talk about the scales first. So we have a compass rose going around the outside of the device, so north, east, south, and west. And just inside we have what they call an index angle scale, which many of you are familiar with as a relative wind angle. And that goes from 0 to 180, and then 180 back down to 0. And we use that for calculating wind correction with the law of sines. Moving in then, we have this less than 2-decade logarithmic scale right here for wind velocities slowly morphing into true airspeeds. So that goes from a wind velocity of 10 all the way up to 280 on the true airspeed side. Then we have 2 sine scales, which go from 1 degree to 90 degree on this inner scale and 2 degrees to 90 degrees on the outer inner scale. And then we have this tiny little ground speed scale right here in the middle. Now, something I like about this device is that it's self-documenting, so it sort of walks you through the steps of 1, 2, and then there should be a 3 here for calculating ground speed. You actually do see the 3 when you look at the revised version here, 1, 2, 3. So we'll just go through those steps for this particular problem. So, given a true course of 270, a wind of 120 at 26, and a true airspeed of 150 miles per hour, let's find our index angle, our correction angle, and our ground speed. So it says, first, turn disk to set variation east or west opposite course. Now, I'm actually not sure what that's all about. Must assume that you're already looking at a magnetic variation rather than a true course. So we're going to actually do that a little bit differently and just treat this as if we're flight planning rather than actually flying. So we'll set our true course, which is this line right here, to our true course, which is a heading of 270 or west. So we set that up like that. Next, we read the index angle on the disk opposite our wind direction. So our wind is coming from 120. We come down here to 120, and we read our index angle on that inner scale of 150. So that is our index angle, or our relative wind angle. And then we move on to step 2, which is move the disk to set the index angle opposite our true airspeed. So our index angle of 150 has to be set across our true airspeed of 150. So here's my true airspeed and 150 lined up against 150 there. And it says, next, read the correction angle opposite our wind velocity. So our wind velocity is 26 miles per hour. Across from our wind velocity here of 26, we can read a 5-degree correction angle. And that wind was from the left, so that'll be correcting to the left, 5 degrees to the left. And then for our final step, step 3, without moving the disk, subtract the correction angle from the index angle and read the ground speed opposite the angle found. So 150 minus 5 is going to give us 145. And if we come here and find 145 on this teeny tiny little sine scale here, it's going to be this line right here. And we move on up and read something that's between 170 and 175. So we'll call that a ground speed of 172 miles per hour. Okay, so there are a few limitations here. One is that we can only use true airspeeds up to 280 miles per hour or units. depending on what units you want to use, as long as they're consistent. Probably not a big deal for airplanes around 1940, and also probably not a big deal for general aviation airplanes today. So that covers those speeds quite well. Something that should be mentioned though is that we've compressed this sine scale into essentially half the circle, which makes it much harder to read than if you were to look at something like the dry Kreshner, where you've got a the sine scale wraps around the entire device. So you've got a lot more resolution and the ability to set your wing correction angles without squinting and straining your eyes. But there we go. We've got a rough idea of our ground speed and our correction angle. And so then we'll turn it around to the other side of the device and try to answer this question, which is, given that ground speed, how much time do we need to fly 400 nautical miles? Now, before we do that, I just want to take a look at this device. Take a look at the scales on this side of the device, because it's a little bit different than what we're used to seeing. So on the outer scale here, we've got distances that go from 18, and that wraps around all the way to distances on the other side of 1,000. But notice that those values don't wrap around cleanly as in sort of an even decade. I'll talk about what that means in this. Actually, we'll just talk about it now. So if I were to set my rate, say I was doing 500 miles an hour, just to keep this simple. In 1 hour, I would be doing 500 miles over the ground. In 2 hours, I would be doing 1,000 miles. And in 3 hours, I would be doing 1,500 miles. But the problem here is that this isn't a wraparound scale. So once I've gone off the scale here, past the top of the end, I can't do those calculations anymore. And so that sort of initially seems like it'd be a limiting factor in the use of this device, but we'll see why in a second. It's actually, there's a reason for it. As we move in, then we've got a time scale, which goes from 10 minutes all the way around to 8 hours. And again, for airplanes at the time, that's about as long as you would consider flying. And so you don't have to worry too much about times past that. Same thing for general aviation. Hard to believe that you would take a small airplane up for more than 8 hours in a row. Okay, so let's go ahead and work through this problem, and we'll talk about what's actually quite nice about the solution here. So in order to figure out how long it's going to take to fly 400 nautical miles, we set the 1 hour mark opposite our speed in miles per hour. So 172 miles per hour is what we calculated in that other problem. So that's going to be right there. It's 170, and then these little ticks are by 2, so 172 miles per hour. And then we look across from 400 miles on the outer scale and read our time that it's going to take to fly on the inner scale, which is 2 hours and 20 minutes. Now, you might not have noticed what was so nice about that. I think to see what was so nice about it, let's actually go ahead and set up the same problem here on an E6B. So for that, we would take this arrow, which represents 60, but it's not marked as 60, and we would have to set that across from not 172. This is where it gets a little interesting. We actually set it across from 17 or 17.2. It's a subtle difference, but here we actually get to set our speed on 172, and here it's 17.2. So if you don't like keeping track of decimal points, well, this is a great flight calculator, and that you don't have to, because all of the speeds and times that you would use are directly there on the device. Whereas on an E6B, you have to keep track of those decimal points. And again, to fly 400 nautical miles, we don't actually read 400 on the device, we read 40, which we have to put an extra 0 on there, and then we have to come on down here and then read our answer of 2 hours and 20 minutes. All to say that even though the Jardur Model V does not have wraparound scales, it does have the advantage that you can just read the answers directly from the device. So that's it. That wraps up this video on the Jardur flight calculator, and thanks for watching.